Hey everyone, welcome back to the channel. Today we're jumping into something super exciting and actually really useful, especially if you're into audio or embedded systems. So here's the plan. We're going to build a high quality Bluetooth audio receiver using the ESP32 along with an external DAC module, something like the CJMCU 1334 now. Whether you're a student just starting out with embedded audio, a hobbyist experimenting with the ESP32, or honestly just someone who appreciates good sound, this video is for you. We're going to walk through everything step by step. First, how Bluetooth audio actually works on the ESP32, then how to wire up the I2S DAC for clean, crisp sound. We'll write and upload the firmware together. And of course, test it all out by streaming real music from your phone. By the end of this session, you won't just have a working Bluetooth speaker, you'll also understand key concepts like what is Bluetooth A2DP, how the ESP32 sends audio via I2S, and how to connect microcontrollers with external DACs for real world audio projects. So let's dive in and explore how Bluetooth audio really works together. Alright, so before we jump into building stuff, let's just take a quick moment to understand how all this works behind the scenes. And don't worry, I'll keep it beginner friendly. No heavy theory, I promise. We're going to hear a few new terms like A2DP, I2S, and DAC. And well, if those sound kind of intimidating right now, they're really not. So let's just break them down one by one. First up, A2DP. Okay, so A2DP stands for Advanced Audio Distribution Profile. It's like the Bluetooth protocol that's responsible for sending high quality stereo audio from one device to another. So when you stream music from your phone to, say, Bluetooth headphones or a wireless speaker, yeah, that's A2DP doing all the work in the background. Now, in our case, what happens is your phone will be the A2DP source, meaning it sends the music, and the ESP32 will act as the sync. Basically, it receives that audio stream. Pretty straightforward, right? Next up, DAC. So, DAC stands for Digital to Analog Converter, and this one's super important. See, when your ESP32 receives audio over Bluetooth, it's just a bunch of digital data, ones and zeros. But here's the thing, your speaker, it doesn't speak binary, it needs analog signals, smooth, wavy voltage patterns. That's where the DAC comes in. It takes that digital stream and converts it into analog audio, something your speaker or amplifier can actually play. We'll be using an external DAC module for this, something like the CJMCU 1334. It gives us much better sound quality than the ESP32's internal DAC, which is honestly a bit noisy and limited. And finally, I2S, pronounced I squared S. So I2S stands for Inter IC sound, and yeah, it's kind of like a digital highway just for audio. It's a special communication protocol that lets microcontrollers, like the ESP32, send audio data to other chips, like our DAC. And it does this like super efficiently. Very little delay, almost real time. So basically, your phone sends the audio over Bluetooth, the ESP32 picks it up using A2DP, then passes that digital audio over to the DAC using I2S. The DAC takes care of converting it into smooth analog sound that we can actually hear through a speaker. And at this point, right at the DAC output, we can also connect a small audio amplifier, like the PAM8403, if we want to boost the signal before sending it to our speakers. That way we get louder and cleaner sound, especially when driving passive speakers. So yeah, that's the full audio pipeline from your phone all the way to your ears. Alright, so now that we kinda get what I2S is all about, let's talk about how the ESP32 actually handles I2S audio. The good news is that the ESP32 has a built in hardware, I2S peripheral. So that means it's totally capable of sending and receiving high quality digital audio with like really low latency and solid performance. Here are some important I2S features of the ESP32. So, first off, it supports two I2S controllers, I2S0 and I2S1. Each of those can be configured to work either as a master or slave, and they can, either transmit TX or receive to RX audio, depending on what you need. And it supports audio sample rates all the way from 8 kilohertz up to 192 kilohertz, which is like perfect for music playback. Now, in our project, we're going to use the ESP32's I2S peripheral in master transmit mode, right? Because basically, we're sending digital audio out to the DAC, and that DAC acts as the receiver here. Okay, so to send digital audio from the ESP32 to our DAC, we need three key I2S signals. Let's break those down real quick. PCK or bit clock. This signal tells when each bit of audio data should be sent. This is like a tiny timer that tells the DAC when to read each bit of sound data. LRCK or WS, left right clock or word select. This tells the DAC whether the current audio data is for the left channel or the right channel. It alternates between left and right, so the DAC can play stereo sound correctly. Data, serial data out. This carries the actual audio samples. The digital values representing sound. These are sent bit by bit in sync with the bit clock. Together, these three lines let the ESP32 stream high quality stereo audio to the DAC in perfect rhythm. And one of the great things about the ESP32 is that I2S pins are not fixed. You can assign almost any GPIO to these signals in software. Alright, now let's take a look at the circuit diagram. So here we've got the ESP32, and right next to it we have our DAC module. In this example, I'm using the CJMCU 1134, but honestly, you can use any I2S DAC that's available to you. As long as it supports the standard I2S input, it should work just fine. Now, if we look at the wiring, we're connecting the ESP32 to the DAC using three main pins for I2S communication. GPIO 26 from the ESP32 goes to the BCK pin on the DAC. That's the bit clock. GPIO 25 connects to LRCK, also known as the word select or left right clock. And GPIO 22 goes to DIN. That's the digital audio input on the DAC. Apart from that, of course, we connect the power and ground, 3.3 volts or 5 volts depending on your DAC module, and GND to complete the circuit. Now the output of the DAC gives us clean analog audio. But that signal is usually pretty weak. So before sending it to a speaker, we pass it through a small amplifier. For example, you can use something like the PM8403 module. It's super easy to use and works well for small speaker setups. And yeah, this whole circuit is actually pretty simple once you get the hang of it. I've also attached the full diagram in the description box below, so feel free to check that out and follow along while building your setup. Alright, let's walk through the code real quick and I'll explain what each part is doing in simple terms. This will help you really understand how everything works under the hood, not just copy and paste blindly. So first up, we include a couple of important libraries. Basically, these two libraries are the brains behind this whole thing. One lets the ESP32 receive high-quality Bluetooth audio using something called the A2DP protocol. Remember that from earlier? And the other handles I2S digital audio output, which sends that audio to our external DAC. And next, we define the I2S pin numbers we're going to use to connect the ESP32 to the DAC. Something like this. We create an I2S object like this. Think of this like a controller that manages how the ESP32 sends audio using I2S. It's what we'll use to set the audio settings, like sample rate and format. Then we make a Bluetooth A2DP sync object and link it to our I2S setup. What this does is it sets up the ESP32 to act as a Bluetooth speaker. So when your phone connects and sends music, that music will be automatically forwarded through the I2S output to the DAC and then to your speaker. Pretty cool, right? Now we move into the setup function, which runs once when the ESP32 starts. This line tells the ESP32 which pins are connected to the DAC. So now it knows exactly where to send those I2S signals. Then we initialize the I2S interface with the audio settings we want. We're setting it up to use standard I2S mode, 44.1 kHz audio sample rate, 16-bit audio, and stereo channels. If something goes wrong, it prints an error and stops. Alright, next step, we start the Bluetooth audio service and give our ESP32 a name. So this is where the Bluetooth part kicks in. Your phone or laptop will see a device named My Music when it searches for Bluetooth audio devices. And once it connects, the ESP32 will start receiving the music and streaming it through I2S. The loop function stays empty because everything's handled automatically in the background by the Bluetooth and I2S libraries. So we don't need to write any logic here. It just works. And that's it. That's the whole setup. Simple, clean, and super powerful. From here, we just upload the code. Alright, so once you flash the code onto your ESP32, just head over to your phone's Bluetooth settings and you should see a device named My Music pop up. Go ahead and connect to it. And as soon as the connection is made, you'll start hearing your music play through the hardware setup we just built. Pretty cool, right? And well, that's all for this video. Thanks a ton for watching, and if you found this helpful, don't forget to give it a thumbs up. Maybe subscribe if you haven't already. And I'll catch you in the next one where we'll keep building more awesome stuff.